Okay, so we've introduced x squared graphs, quadratics. So let's talk about it, quadratics. Quadratic functions. And we had looked at in our previous lesson, us graphing it, for instance, or us not graphing, us talking about how to solve it. So give me a moment. We worked on solving quadratics. So if I gave you x squared plus 6x plus 8, we said the way for us to solve this is by factoring. We have to know that method. Hey, we can't solve it in our regular Algebra 1 August way. We have to use our method called factoring. Two numbers that multiply to become 8 is 1, 8, and 2 and 4. Now, which of these options add up to 6? Hopefully you said 2 and 4. X, 2 and 4. Plus plus means there's going to be a plus plus here. And we solved them separately. We said x is equal to, x plus 2 is equal to 0. X plus 4 is equal to 0. Minus 2 to both sides. X is equal to negative 2. Minus 4 to both sides. X is equal to negative 4. And we said these values here tell me what value, what x would have to be to solve this to equal to 0. The goal is to get to 0 here. So if we plugged in negative 2 and we practiced it, we said negative 2 squared plus 6 times negative 2 plus 8, does that equal to 0 to you? Doesn't look like it, but once I do the math, 6 times negative 2 is negative 12 plus 8. 4 minus negative 12 is negative 8 plus 8. Bam. We actually end up with a 0. Now, what does this mean? Like, great, I solved for 0. I was able to get to the goal you set for me. The goal is find an x value to make this go to 0. And what we're talking about here is a point on the graph. So when x is negative 2, negative 1, negative 2, and x is negative 1 here, this is where the graph, the y value is 0. When x is negative 1, that's a 4 there, right? I looked at it the wrong way. I couldn't read my own writing. Negative 4, negative 1, 2, 3, 4, negative 4. So the point is, when x is negative 4, my y value is 0. And the other point is, when x is negative 2, my y is 0. These are the only times I can get to 0. Now, how would I try to connect this in a graph? Would I draw a line like this? No. So we have a special type of graphs for these. And these are called parabolas. And in this case, it's going to be upward facing. And it looks something like that. It's almost like I took a stick and I bent my stick to go through these 2 points. And this is what we call a parabola. And it's this U-shaped graph. And in this class, we'll get to graph this. So when we first started Algebra 1, we talked about x and how to solve for x. And then we went and graphed x and say, hey, x is great. And how could I visually see it? Oh, it's the graph of a line, a simple line. Let's go ahead and look at that on the side real quick. If I say y is equal to 2x plus 1, we said this is my slope. And the y-intercept, we graphed it as 1 rise 1, 2 over 1. We're able to say this equation, y equals to 2x plus 1, is a shape of a line that keeps rising. 1, 2 over 1, 1, 2 over 1, 1. That's the rate at which I'm making money. It's increasing. Now this parabola here on the left, x squared plus 6x plus 8, this is the shape of any x squared graph. All x squared graphs always have this U-type shape. Now let's talk about why does a U-graph shape have to do with x squared? And there's actually a hint there. It's because of the x squared. X squares make parabolas. X squares make parabolas. Now, let's give you guys an example of us plotting points for a parabola. If I said y is equal to x squared versus y is equal to x, okay? We see that this guy is my quadratic. And this is what we call linear because it's a line. Now, if you guys can memorize this now, you guys will be set all the way to high school. That whenever you see x squared as my highest exponent, that's my lead guy, x squared, you're going to end up with a parabola. If you see just x by itself, that's your biggest exponent, just 1x, well, that's going to be the shape of a line. So automatically I can tell you this is going to be a U shape, and this is going to be a line shape. It's like you being able to recognize someone who's rich or not. How do you recognize that they're rich? You look at their shoes, you look at their car, you look at their house. Oh man, you're ballin'. How'd you know? Well, look at your car that you're driving. But in our simple way of looking at math functions, if I see x squared, I know you're a parabola. I know you're going to be some type of U shape. And if I just see an x by itself, we know you're just a line. Now let's go ahead and talk about why is it a U shape. Well, let's create a t-table, x and y. And we're going to plug in x values here, and we're going to get our y values from x squared. So let's go ahead and plug in some easy values. We're going to do, skip some space, 1, 0, 1, 2. Now, let's go ahead and plug it in. We're going to end up with 0 squared equals 1 squared equals 2 squared equals. So all this stuff is going to happen here. 0 squared equals 1 squared equals 2 squared equals, okay? And then what's 0 squared? That's 0. 1 squared is 1. 2 squared is 4. Does this look like a nice straight pattern? I go from 0, then to 1, and then I jump to 4. Imagine if someone paid you that way. First day you work, you got nothing. Second day you work, you got $1. Third day you work, you got 4? Huh? What if you work another day? Next day you work, you get 9. I like this. I went from making $1 extra to making $3 extra to making $5 extra. Is growing in a weird way. And this x squared graph, because I'm squaring it, is increasing what I'm going to earn every step I take. So let's go ahead and graph that. So when x is 0, the y is 0. When x is 1, y is 1, right? That's my 1 value there. When x is 2, 1, 2, 3, 4, up here. And you can say, does that look like a line? Well, let's take a ruler here. And if I connect the first 2 line points, does that look like a line? What if I connect the second 2 points? Does that look like a line? Can I draw one line to connect all 3 of them? Well, if you kind of mix it in the middle, yeah, but you see, I'm not really hitting everything. It's kind of a blur. If I do my last point, and the third one becomes really obvious. If I put 3 here, 4, 5, 6, 7, 8, 9. Do you guys really want to graph this many spaces out? Let's take a look. These 2 don't connect. These 2 connect, but the third one doesn't. And these 2 connect, but then they connect with no other line. If it was in a line, all 3 points would touch. But even in my basic drawing here, none of them touch. Why? It's because they form this U shape on the right. And as the further I go, the faster I get. It's like a rocket. See, it's literally going to the moon. It is not going in a straight line. If it was a straight line, it would go in this direction here. Now, I want to ask you this question. If you bought something to invest in, let's say you bought a comic book, you bought a Pokemon card, you bought something that you thought you could make some money with, you bought some stocks. Which pattern would you rather have it grow at? Would you rather have it grow at x squared, shooting off to the moon? Or would you have it grow in a nice, simple line? Which one do you think would make more money? And hopefully you're seeing that the x squared, yeah, x squared is always going to make you more money. Why? Because when you square something, you grow it faster. 2 squared is 4. 3 squared is 9. 4 squared is you're going to jump to 16. 5 squared, you're at 25. Right? If this was a regular line, you'd probably be only at 10. So that's why parabolas look very different, because they grow in a different rate. Now, why does it look like a U? Now let's take a look at the left side. If I plug, let's go back and write on the left side. If I put -1 squared, -2 squared. So tell me, take a look what happens to that. What happens when you multiply a negative by a negative? A negative 1 times a negative 1, let's write out a negative 1 times a negative 1. The negatives cancel out, becoming a positive 1. A negative 2 times a negative 2. What do you think happens to those negative signs? A negative times negative becomes a positive. This is positive 4. But there's something weird also going on. It's like I'm having deja vu. You guys ever have deja vu where you felt like you've seen this before? Well, we have seen this before. Because the numbers on the left side of my parabola mimic the numbers on the right side of the parabola. So what does this look like in the graph? Well, it looks like on the left side, if I go one space over, we're going to end up at positive 1. What if I go 2 spaces over? These are negative. It's going to be positive 4. But you stuck in a negative value, Mr. Ko. You're right. But when I square it, it becomes positive. If I put negative 3, I'm running out of space here, but what if I put negative 3 here? Negative 3 squared is positive 9. Negative 4 is positive 16. So we get this mirror image going on. And let me go ahead and try drawing this on the other side. And in order to hit all those points, I don't have a line, I have this curve. And this curve in this U shape is called for us a parabola. And if you guys could say that out loud in your homes, parabola, parabola. Literally, it's parabola, okay? Parabola. And this refers to this U shape. What happens on the left side looks like the right. Now, we could say this is like a mirror image, isn't it? A mirror image. And so we have, this is reflected. And we want to use a fancy word to talk about how this is reflected. And this is called the axis of symmetry. Let me double check if it's 2 M's or 1 M. I always forget. My spelling is atrocious. Okay, it's 2 M's. Axis of symmetry. And the axis of symmetry is where does it mirror itself? Can someone look here and tell me at what value of x? Does it happen at negative 2? Does it happen at negative 1? Does it happen at 0? Does it happen at 1, at the 2 or 3? Where, at what x value does it start to flip itself over? So does it happen here? Oh, come on. Does it happen here where the left side looks like the right? Does it happen here where the left side looks like the right? Does it happen here where the left side looks like the right? So the x value here for us is actually going to be right at 0. This problem is going to be simply at 0. The axis of rotation, axis of symmetry is going to be at 0. Oops. Okay. At negative 1, well, it doesn't look like a mirror image of the left looks like the right. Okay. When you look at a person's face, right, 2 eyes, we usually have axis of symmetry right at our nose. And they say in art class, when you have a model, why does a model look prettier than you or me, let's say? It's because they have a line of symmetry across their face. Their left side looks like their right. It's not like one eye is bigger than the other. Okay. So this axis of symmetry here is where does the graph cut it in half so the left side looks like the right. Okay. What are other words that we have here to describe what's going on? We actually have a lot. We have another word. Let's go ahead and do it since we're here. We have something called the vertex. The vertex. The vertex is an x and y point. Where does the point meet? At what point do these lines meet? If you guys know about vertices in a rectangle, these are where the lines meet. That's a vertex also, the same idea of vertex. So at what point do we have this parabola all of a sudden decide to change his life around? And in this case, our vertex is going to be at 0, 0. We have another word that we have to look at. Another word is the X-Intercept. In this graph, where does this graph run into the x-axis? And this is a word that we talked about before, the x-intercept. So at what value here does the graph run into the x-axis? X equals to 0 here in our case here. Perfect. Another word can be used is called the origin, is 0, 0. In this case, we're at the origin here. So the vertex is the point where they meet. That's a vertex. We have also, lucky for us, our axis or our x-intercept is also at 0, 0. And we have one more thing we want to talk about today, is what is the minimum? What is the lowest point on this graph? What is the lowest point on this graph? What is the lowest point on this graph? And hopefully you can see it's where the dip is right in the middle. So in this case, y is equal to 0. Because this is an x value, this is a y value. What's the lowest y value? The lowest y value is at 0. Give me one second. So these are our 4 words that we're going to be working on today, and that's what you will be practicing in your IXL. Tell me what the vertex is, the axis of symmetry, what the minimum, the lowest value is, and what are the x-intercepts. Now let's go back to our last problem that we first started off this whole class with. And we worked on this problem, y is equal to x squared plus 6x plus 8. Okay? We said a couple things already that were pretty clear about this graph. We found out where this graph is equal to 0. And we said it was going to be at -2 and -4. I drew the graph in such a way that the parabola looked like this. I'm going to give you another point here for you. That point is going to be -3, comma, -1. Right? The point right where everything turns around, we have -3, -1. Now we're going to talk about all the parts that we just talked about, the 4 words. We're going to talk about the vertex. What is the vertex? What is the axis of symmetry? Okay, and that's a x equals 2 in this case. What is the minimum? Oh, minimum is a y value, I'm sorry. And what is the x-intercepts? Okay, and those really are the 4 words that we're working on today. So look in this graph, what is the vertex? At what point does everything kind of collide? Hopefully you can see, it's actually kind of obvious here. It's at -3, -1. That's where everything collides. What is your axis of symmetry? At what x value does everything all of a sudden get flipped? Let's take a look here. Does it happen at -4? Does it happen at -2? Or it happens right in the middle here at -3? Okay, see, it's actually really easy. Okay, good job. -3. If the problem is, if they ask me these vocabulary words,
yeah, I'm gonna run to my car to get something. Thanks.
okay, and then last one, what's the minimum? What's the lowest value? Okay, so let's take a look. This graph shoots up, so we have a high, we don't have a maximum, but the lowest value we get to, take a look here, is -1. Any x-intercepts, looking here, when does this graph touch 0? It happens at 2 places, and we are able to solve for it. When x is equal to -4 and -2. Okay, and that's it.